To make this mid-engine Peugeot 205 possible, I need to connect the subframe to the wheels and brakes. The original Volkswagen upright won't work, because I'm completely changing the suspension design. Modifying the original one would be too difficult, nearly impossible to do accurately, and comes with a huge risk.
Ujebali mi koleso!
That means there's only one option: to build a completely custom upright. And if I can't make this part work, the whole project is in serious trouble. Everything starts with parts I have to keep: the Volkswagen wheel bearing and wheel hub. These are essential, because they connect the drivetrain to the wheels. My driveshaft, bearings and hubs all have to work together, so these dimensions are fixed. To use them, I first had to recreate the bearing housing from the original upright. Precise measurements here are critical. Even small error would affect the bearing fit, the brake position, suspension geometry, basically everything. This 10mm steel plate became the main part of the entire upright. It holds the bearing housing, it carries the brake caliper, and thanks to these slots, it also locates every other mounting plate in exactly the right position. The bearing housing was machined by a local shop, while all the steel plates were laser cut. Thankfully, the housing fitted perfectly, with the help of a hammer. My workbench, however, wasn't enjoying that process. Luckily, this groove positioned the housing exactly when I needed it to be. So once it was seated, everything lined up nicely. Maybe that wasn't going to be so difficult after all. I'm really grateful that one of my dad's friends let me use his workshop, because at that point I basically owned none of the equipment needed to build something like this. Until that moment, I honestly thought welding was pretty simple. You melt two pieces of metal together and that's it. Turns out, keeping them in the same shape afterwards is the hard part. Yeah, that's as straight as the newest Jaguar. I probably should have clamped everything before welding, but a hammer can easily compensate for the lack of competence. At least, sometimes. Once the main plate was finally straight again, I needed to design a connection to other parts of the suspension. That meant creating mounting points for the upper control arm, lower control arm, and the toe link. One of the biggest advantages of designing everything from scratch is that I wasn't limited by an existing upright. Every mounting point could be placed exactly where the suspension geometry needed it to be. The downside? Every mounting point also has to be strong enough to survive forces suspension sees when the car is actually driven. And those forces can get bigger than I expected. I also wanted the whole assembly to be as easy to fabricate as possible, which, considering my welding skills at the time, was probably the most important design requirement. Of course, I also tried shaving off as much unnecessary weight as I could, even though I knew from the beginning this wasn't to be the lightest upright ever built. But I'd much rather have something a little heavier than something that could give up at the first track day. It's also a prototype, so we can make it better later. To get an idea of where the structure might flex, I made a very scientific structural analysis. By scientific, I mean Blender visualization and a simple common sense. Even that was enough to show that the mounting plates could still bend under load. So I designed this additional backplate. Instead of every mounting tab trying to bend on its own, they now became part of an enclosed box structure. Now the suspension loads don't just try to bend individual plates anymore. They have to compress a thick steel backplate. And good luck with that. This place also solved another problem I knew I was going to have: accuracy. Because every mounting plate sits flush against the backplate, they automatically position themselves at right angles. That means fewer measurements, fewer opportunities to mess something up. With my fabrication skills, that sounded like a necessity. At least that was the theory. I welded everything together, added a pair of small reinforcing plates, and for a brief moment I actually thought everything had gone exactly according to plan. Then I noticed this. One of the holes was, let's call it, slightly misplaced. After checking everything, I realized the mistake wasn't in the cut model. I just went straight to welding without checking the laser cut parts. At that point, to avoid scrapping it all over, I welded the hole shut. Grounded everything flat, then traced the correct position and drilled a new hole. It worked, which meant there was still hope after all. Now I only had to do another one. Right after that came the moment I've been waiting for since I started designing this part. Would everything actually fit together? Were my measurements correct? To know that, the first step was installing the bearing. For that, I used a hydraulic press and a setup that looked too sketchy to work. But somehow, everything went surprisingly well. The bearing seated exactly where it should. Next came the retaining clip. Small, but important. Then it was finally time to press in the wheel hub. And just like that, for the first time, the upright actually started looking like something that belonged on a car. I managed to install it correctly enough to make the hub actually spin quite freely. At this point, I finally had two complete uprights. Hours of designing, days of fabrication, and somehow they actually existed. But there was still one big question left. One that would decide whether all this work had produced a functional suspension component or just two very complicated pieces of welded steel. Would the brakes fit? Without that, we're cooked. The donor brake discs had definitely seen better days. They were rusty, and to make things even better, one of my welds was just touching the braking surface. So I carefully cleaned the interference with an angle grinder, then took both discs to a machine shop for resurfacing. When they came back, they looked better than new. Despite that success, I made another small mistake. I completely forgot to thread the caliper mounting holes before welding everything together. Thankfully, the machine shop rescued me once again. We drilled the holes to a correct size, then threaded them. This moment meant a lot. For the first time in this project, something I designed completely from scratch, fabricated myself from a pile of laser cut steel, had become a real car component. One that actually worked together with the factory parts. It proved that the project wasn't just staying inside of my computer anymore. The project was becoming something real. Until I tried fitting the upright to the lower control arm. But that's another story, and one we'll cover in the next episode. Thank you for staying, and if you want to become a part of that journey, subscribe to get an update on the build.